क्या जी बच्चे नहीं ज्वाइन कर रहे? Hello, am I audible? Just one. Just one. Just one. Can you hear me? Yes.
Yes, ma'am.
Okay, fine. So you were there in last period or not?
Ma'am, last class, yes,
Starting
ma'am.
with the periodic table, you were there or
Yes,
not
ma'am,
that time?
please. Ma'am, I was there.
You were
I was
there?
there. Yes, ma'am.
Fine. Why you joined too late today?
Yes, ma'am.
Fine. So actually, I just recapitulate the things which we have seen into the last period, because since last 3 days like happened, nothing is like not a single period is happened in these last 3 days. So I'll just revise a few things, and after that we are going to continue for the Mendele's periodic table. Okay.
Okay, ma'am.
Let others join or not. I'm going to continue with you because it's too late now, around 4 o'clock. I don't want to waste your time. Fine. Okay. See here. Okay. I have explained you about the Doberner's traits, right? Yeah. In
Yes,
the
ma'am.
previous period, I have explained you about Doberner's traits. What it is? What do you mean by Doberner's traits? It's a group of 3 elements, correct? It is a group of 3 elements. How many elements are these? 3, right? Yeah. The
Yes.
example is there in front of you: lithium, sodium, and potassium. Their atomic masses is given to you. That is what? 7, 23, 39. What is the relation among the three? Like average atomic mass of these two would equal to the middle element's atomic mass. Okay, that we have to see here. Right? 7 plus 39 upon 2. Yeah, what it will be? Upon 2. That is equal to 23. Correct? This is the atomic mass for sodium. This is called as what? This is called as what? Doberner's traits. Right?
Yes, ma'am.
Yeah. Fine. Now, see what is next in this. Law of threads referred to seem only into the few elements. It was dismissed as the coincidence. Why? Because it is followed with certain elements only. All element does not follow Doberner's thread. And that time hardly few elements were known, right? And those were known among that also only few elements were follow these threads. And
Hello,
hence,
ma'am.
yeah, hello, who's there?
Yeah, ma'am. Good evening, ma'am. This is Shashi, ma'am. I'm actually an existing student, ma'am. I just joined today, ma'am.
Okay, you are new student, correct?
Yeah, ma'am. I'm an existing student, ma'am. I just have joined late, ma'am. Yeah, ma'am.
Okay, you have joined late. Fine.
Yeah,
So,
ma'am.
what you expecting from me? Means, shall I explain again?
No, ma'am. For that, I'm been watching the recordings right now,
Okay, fine, no issues then. So,
and
shall I with my
yeah, yeah.
content whatever I'm teaching right now? Please focus on it. If you feel any problem, please let me know so I can try to resolve your problems and the queries. Okay.
Ma'am, actually, I'm not too ahead in the recordings, ma'am, because there are several classes which are done, so I might not be able to understand.
Whatever you will not understand, na beta, you do one thing. Just make a note of it and send me on my WhatsApp. I'll try to clear it in the periods. Okay, wherever it is,
Okay,
whenever it is.
okay.
Okay. And
Yes,
apart
ma'am.
from that, recently we have started with a new chapter. This is a new chapter, okay?
Yeah, ma'am.
Periodic table and the properties of elements. So
Okay,
this
ma'am.
chapter we are going to see thoroughly. And one period only happened for this chapter. Already I have explained everything, basic things regarding this chapter to the children. And hardly I think one or two children are joined today. So let it be no issues. I'll explain you once again. I don't have any problem. But then Jaswant would be ahead, I guess. He already gone through it.
Yeah,
It's
ma'am. Yes, ma'am.
for him. I'll just take a permission from him whether he able to once like he allow me to reteach this part or not. Jaswant, what you
Ma'am,
say?
yes, ma'am. Ma'am, it's fine.
Fine. Okay.
Yes, ma'am.
Yeah, ma'am.
And what about other students? They are not there or what today?
Yeah, ma'am. Just two.
Just two. That's what. Okay. Let it be no issues. So earlier there were hardly 60 elements, right? And
Yeah.
number of elements, like as time gone, scientists discover several number of elements. Until the date, we are aware of what there are how many 118 elements, correct?
Yes, ma'am.
Yeah, 118 elements. In your book, they have given 116, but then at least 118 elements everyone should know. So these elements are really very like each and every element form a several compounds. That is also true. Everybody is aware of, right? And
Right.
if we see about the carbon, carbon itself have a separate branch of chemistry that is organic chemistry, right? Which forms a tremendous number of compounds, and it is very difficult to classify them and group them together. And because of that, classification of elements was really very essential. Correct. So there are different scientists who try to do this from early of the century, right? And there are certain scientists whose work we have to see in this chapter in detail. That's it, nothing else. Okay. And history, we know that it's very important to like seek for the future, isn't it? So that only we have to see in this chapter. So the part first that we have to see that is nothing but what Doberner's trade, right? Who was the Doberner? Doberner was the scientist, right? Who tried to classify the elements. What he did in that? Yes, what he did in that, he arranged the elements according to increase in their atomic weights. He found out the trades of element. What he found? Trades of element. What is the trade? It is a group of three element. What is the trades? It is a group of three element.
Okay.
Okay. And in this three element, suppose there are the three element A, B, and C, right? In that, the middle element would be has a atomic mass equal to the average of other two elements' atomic masses. Means atomic mass of B is equal to average of atomic masses of A and C. Okay, this formula you have to keep it in your mind. This is what Doberner's trade. And earlier there were hardly few elements were known, and because of that Doberner's trade become quite famous, and he might got a few awards as well for this. But then all elements were known that time were not fit into this trades, and this is a limitation of this Doberner's trades. Understood? Yes. So there are the certain limitations in this, and because of that, we have to find the another solution or another way of classification. And if you want to see the realistic example of this Doberner's trade, this chart is given to you in your textbook. If you see, right? Here are three elements: lithium, sodium, potassium, calcium, strontium, barium, and here chlorine, bromine, and iodine. Able to see? Yes. Hello.
Yes, ma'am.
Fine. Now, just now I have explained before you come to the just one about this lithium, sodium, and potassium. If you see their atomic masses, how much it will be? For the lithium, it would be 7. For the potassium, it is 39. And for sodium, it is 23. So we just have to see whether it's followed Doberner's trade or not. So which one is the middle element in this? Sodium, correct? We have to check the mass of sodium, whether it is equal to the average mass of lithium or lithium and potassium or not. So for that reason, what you're going to do, average mass of lithium and potassium is equal to 7 plus 39 upon 2. That is equal to 39 plus 7 is 46 upon 2 is equal to 23.
Yeah, right.
Correct? Yes. So what you come to know? What you come to know by these? In a Doberner's trade, middle element has an atomic mass equal to average atomic masses of the other two elements in a trades. Understood? But this law of trade is dismissed. Why? Because it is followed by hardly few elements. All elements does not follow this Doberner's trade. So you have to do what? You have to calculate the atomic masses, average atomic mass for the strontium, whether it shows the Doberner trade or not, and similar for the bromine, whether it shows the Doberner trade or not. See, keep it in your mind. There would be little, like what we can say, little difference in the actual value of atomic masses of the middle elements with the average value. Okay, decimal point like difference would be allowed. That's fine. You have to consider the whole number. Means you have to round it up. Okay, if near about value you will get, that too fine. Can you do this? Yes. Just one. Yeah. Go for it. How you're gonna do? See, for the calcium, strontium, and barium. Then
Okay.
atomic masses you write down. That is given 40. Here 137. Find for the strontium. Check how much it will be. Actual atomic mass for the strontium is 88. Then for the chlorine, then bromine and iodine. Then for the chlorine it is 35.5 AMU. And then for the iodine it will be what? 127. You have to find it for.
Ma'am,
Yes.
for strontium, I'm getting 88.5
That's okay. 88.5 and actual value is
because it is
88.
177. Yeah, average is 177.
Yes. So it is near about value, correct?
Yeah, correct, ma'am.
Fine, no issues. What about this? It will also get more than 80, I guess.
1 minute, ma'am. I'll see.
Okay, take it. It will be 88.5, near about 88, right? Actual value of this average is 88.5.
Yeah, I got 81.25 for the third one, the
Eighty-one
chlorine,
point
bromine,
two
and
five.
iodine.
Yes,
Yeah,
you got the value 81, right? 81
yeah,
point.
it's near around
It
280.
is
So,
near about 80, right? Because bromine have several isotopes, right? So one of the isotope has a value near about 81.25 or like around 81. So this value is also applicable. Fine. Now, after this Doberner, there was another scientist who tried to figure out the classification. But then his efforts also not that worth, and he didn't become much famous. But then yes, he like started that classification, and because of that, your book has mentioned his name that we have to see. What is the name of that scientist? French geologist A.E.B. the Chancotois in the 1862. What he does, he arranged the known elements in order of increasing atomic weights. What he does, he arranged the known element in the increasing atomic weights and made a cylindrical table of element to display. What he did, he made a cylindrical table to display. Correct. The periodic reference of properties, this is also did not attract much attention because it wasn't that useful, right? Though he arranged the all elements, known element according to the increase in atomic weight, he just arranged them in a cylindrical manner. It does not attract the attention of many of the scientists. Why it is? Hmm? Why it is not become famous? Because there wasn't any sort of invention, there wasn't any sort of logic behind that arrangement. Just he arranged in a cylindrical
okay,
table
ma'am.
all the known element in the increasing atomic weight, in the way of increasing atomic weight. Wait a minute, I need to erase this. Is that has been stuck? Extremely sorry. Okay. Now we are going to see the another scientist contribution in the classification of element. That is what? Newland's octave, right? What is the name? Newland. The name of the scientist is Alexander Newland, John Alexander Newland, right? And whatever invention he made in the classification is known as a Newland's octave, right? John Alexander Newland, he was the scientist. Okay, and he put forth the law of octaves. Already I have explained you about the musical octaves, and I think this girl, what's your name, beta?
Ma'am, are you talking about me?
Shriyasi. Shriyasi.
Yeah,
Some,
Shreyasi, ma'am.
okay. So you were not there, but then already I have explained about the musical octave, and it's very simple. Do you know about it? What are the musical octaves?
I don't know, ma'am. I don't know, ma'am.
Yeah. If I say, you say no, ma'am. I wasn't. I was aware about it. These are sa, re, ga, ma, pa, the, ni, sa. Right up to this. Numbers. If I count 1, 2, 3, 4, 5, 6, 7. And again, it will be sa over here. And this would be the 8th number, right? If I go from 1st to 8, what I got to know, my element, not element, this musical octave would be repeated, isn't it? Yes?
Yes, ma'am.
Yeah. Means if I have to play these sa re ga ma pa da ni sa continuously, so each and every 8 time, what happened? Your octave would be repeated, right? Means from here again, if I have to start with sa, re, ga, ma, pa, da, ni, sa, from re, again re will come at the 8th number, isn't it? After this sa, what will come? Re.
Yeah, ma'am.
right? Ga, ma, up to this. If I have to count from the ray, then 1, 2, 3, 4, 5, 6, 7, 8. Correct? Ray come at the place 8. Understood? Yeah? Hello?
Yes, ma'am, understood.
Yeah. Now octave means what? Octa means 8. This name also you need, this thing also you need to understand. Octa means 8. Okay? Means when this John Alexander Newland arranged the atomic element according to increase in atomic mass or atomic weight, what he found, each 8th element have similar property to that of the first. Each and every 8th element has the similar property to that of the first. And these are the Newland's octave. To explain it, he gave us one chart. You can see here is the Newland's octave, right? Lithium, barium, boron, carbon, nitrogen, oxygen, fluorine. These are the 7 numbers, right? And 8 would be exactly come below the lithium, which has a similar property to that of the lithium. Correct? So what we come to know, lithium and sodium has a similar properties. Why? Because lithium and sodium has a gap of how many elements? 8 elements among them. Got it? Similarly, if you count from the barium to the magnesium, beryllium to the magnesium, in these 2 elements also have the gap of 8 elements. You can check it. 1, 2, 3, 4, 5, 6, 7, and 8. Got it? Yes or no? So each and every 8th element. Hello? Am I audible? Hello?
Yes, ma'am.
Yes,
You're
ma'am.
audible.
My mic is not showing like level up, level down of the volume. So I thought like whether my voice is audible to you or not. Fine. No issues. So what you come to know, each and every 8th element has a similar properties to that of the first. And these are the Newland's octave, right? But then Newland octaves also have certain limitation. It is followed up to only calcium. Beyond calcium, we are not able to follow this. Correct?
Oh,
Yes
yeah,
or no?
ma'am.
And because of that, there are the certain restrictions, right? We cannot arrange all known element at that time in the Newland's octave. And hence, these are the limitation for the Newland's octave. Then further, we have to see the 2 important studies made by the 2 different scientists. One was what? Mendeleev, and another is a Mayer. The name of that scientist is here written, see. Lothar Mayer. See this one. Lothar Mayer. Actually, Lothar Mayer and the Mendeleev at the same time, they start working on to the classification of element. But then Lothar Mayer wasn't that famous. And the work done by the Mendeleev was really very appropriate in a logical way, right? He arranged all the known 63 element at that time in the increasing atomic weight. And he made certain periodic laws as well, right? And hence,
Yes, ma'am.
tremendous work is become like recognized by many of the countries, and later he became famous, right? And the modern periodic table is also based on that only. There are the certain modification in the Mendeleev's periodic law, and after that we made the modern periodic table. Actually, we didn't made that, made by the Mosley. You'll come to know soon. Okay, that too I'll explain you. Understood about the Newland's octave and its limitation? Yeah. Hello.
Yes, ma'am.
Yes,
Dhananjay.
ma'am.
Dhananjay, you understood or not?
Yes, ma'am, understood.
Fine. Why you joined too late?
Well, I was connecting my Wi-Fi, ma'am. It was not connecting.
I am not able to hear you. Text me.
Okay.
Fine. Try to join on time, okay? Henceforth. Now we are going to go and see the work done by the Lothar Meyer and Mendeleev. So what Lothar Meyer does in his classification, see. The Lothar Meyer plotted a physical properties such as atomic volume, melting point, boiling point against the atomic weight and obtained a periodically repeated pattern. Unlike Newland, Lothar Meyer observed a change in a length of that repeating pattern. Like Newland found what each and every eighth member has a repeating properties. But then Lothar Meyer found a length, means more than, if there would be more than 8 members are there, then too, there would be certain similarities in the properties. And like, on the basis of properties, he made the classification. He doesn't follow only atomic weight. Okay. Now, Mayer had developed a table of the element that closely resembles the modern periodic table. However, his work was not published until after the work of Dmitry Mendeleev, and the scientist who is generally credited with the development of modern periodic table. Why he is credited for the generation of the modern periodic table? Because he gave a periodic law. He arranged all known elements at that time in increasing atomic weight. Okay. And he gave us a periodic law, that is, the properties of the elements are periodic function of their atomic weights. The properties of
Yes.
are periodic function of the atomic weight. This is one of the important law. If you want to note down, please note, because later for the modern periodic table, same law need to be modified. Okay, instead of atomic weight, that would be atomic number. If you want to note it down, please note down. Okay.
Yes, ma'am.
Understood. Fine. See further what is given to you about this, about the Mendeleev. Okay, Mayer-Lothar work wasn't that famous because of the certain reason. Okay, but then Mendeleev, yes, his work has been remarkable and even be recognized by many countries, that we are going to see thoroughly what he did in his classification, that we have to see. Mendeleev arranged the element in horizontal row and the vertical column. Means, suppose this would be the table. These are the horizontal rows and vertical columns, and there would be the vertical columns. In this way, he has divided the element. Okay. So what is the specific role of these row and column? When you travel across a row, properties would change of element. Okay, when you travel across a row from left to right, that time what happened? Properties of the element will be changed. And properties of element, suppose A, B, C, D, these elements are present into one group. Vertical column he called as what? Group. And horizontal row is nothing but a row only. Okay, understood? So horizontal row and vertical column. Vertical column is, and the element present into the group has similar properties. Right? These things you need to keep.
Yes, ma'am.
These basic things you need to keep it in your mind. Fine. What is given to you in the C? Mendeleev arranged elements in a horizontal row and the vertical columns of a table in order to their increase atomic weight in such a way that elements with a similar property occupy the same vertical column or group. Mendeleev's system of a classifying element was more elaborated than that of the Lothar Meyer's. Why? Because he fully recognized the significance of periodicity and used broader range of the physical and the chemical properties to classify elements. In particular, Mendeleev relied on the similarities of the empirical formula and properties of the compound formed by the elements. He realized that some of the elements did not fit it with the scheme of the atomic weight. Means all element will not fit as per the increase in atomic weight. So he followed the physical and the chemical property, broad range of physical and the chemical property to decide its position in the periodic table. Understand? So he ignored the atomic weight and he gave the what I can say important to physical and the chemical properties. See, he ignored order of atomic weights, thinking that the atomic measurement might be incorrect, and placed the element with a similar properties together. For example, iodine with a lower atomic weight than that of the tellurium. Okay, tellurium would be into the group
6.
6, right? Was placed into the group 7 along with the fluorine, chlorine, and bromine, because we know that now we know fluorine, chlorine, bromine, and iodine. These all are what? Halogens,
Yeah, ma'am.
right? These all are what? Halogens. All these have a same property, same valency, -1, right? And they should be fixed into the same group, because what are the characteristics of group? The group elements present into the group must have similar properties. Correct? So though tellurium has a lower mass than that of the iodine, iodine has a lower mass than that of the tellurium. Instead of tellurium, he kept what? Iodine at the place of tellurium. Understand? And what he assumed, maybe measurement of atomic masses may wrong. Okay, fine. And
Yes.
because of that, his periodic table was quite accurate as compared to other. Okay, clear? Fine. Hello.
Yes, ma'am.
Are you there with me? Because you need to give me reply meanwhile, okay? Otherwise, I feel like whether I got disconnected or you got disconnected.
No, ma'am, I am replying now.
Okay, fine. No issues. Apart from that, see what is given to you in this. Wherever he found a spaces or a gap, he kept that spaces blank, where that time any new element wasn't discovered. And suppose he tried to, like these are the groups. Okay, these are the rows, and he tried to arrange all the elements according to the increase in atomic weight. But then he found like certain properties will not be fit. Suppose here A, B, C, D, here E, here F and G. But then here certain properties of F will not match with B, though they are arranged into the increasing property. F property will be matched with C. So he F kept with what? C. Correct. But in this place he
Okay.
kept a blank. This place he kept a blank. And later he means like try to predict the properties of the element which can be fit below the B. Okay. And like that, several spaces he kept blank, and even he predicted the properties of that new element. Okay. And this is the advantage of Mendeleev's periodic table. You can see here what is given. At the same time, keeping his primary aim of arranging the element of similar properties in the same group, he proposed that some of the elements were still undiscovered and therefore left several gaps in the table. For example, both gallium and germanium were unknown at the time of Mendeleev. Which element? Gallium and germanium. Please
Germany.
note down, because in the MCQ they may ask you. Gallium and germanium. These two elements were unknown at the time of Mendeleev. Okay. So Mendeleev published his periodic table with the gaps. He left a gap under aluminium and under silicon, and called these elements as the Eka aluminium and Eka silicon. Under aluminium and under silicon, he kept a gap, and under aluminium name is given by Mendeleev, that is Eka aluminium. And here Eka.
The Eka aluminium is nothing but gallium right now.
Yes, yes. And
Oh,
Eka aluminium is nothing but what? Eka aluminium is nothing but what? Gallium or germanium? Gallium. And Eka silicon is but germanium.
Germanium.
Okay.
Yes, ma'am.
Later we got to know what? These elements are nothing but a gallium and germanium. Right. And even he predicted the method of discovery of these elements as well. You won't believe. He predicted the method of discovery of these elements as well. So you can understand his logic and the geniusness, how genius he was, right?
Yes.
Mendeleev published his periodic table, and he named those elements as the Eka aluminum and Eka silicon. Mendeleev predicted not only the existence of the gallium and the germanium, but also described some of their general physical properties. Means what sort of oxide they may form, then what sort of chlorides they may form, what would be their valency. Okay, these all properties are found by Mendeleev before discovery of these elements. Some of these property predicted by the Mendeleev is given into the table that we are going to see. Okay. So the boldness of Mendeleev's quantitative predictions and their eventual success made him and his periodic table famous. And because of that, the credit of modern periodic table is given to Mendeleev because he was the first scientist who logically arranged all the elements present at that time. Okay. Understood? Fine. So you can check this periodic, check this table, see Mendeleev's prediction for the elements Eka aluminium, that is gallium, and Eka silicon, that is germanium. Fine. See,
Yes.
for the Eka aluminium, he predicted the atomic weight 68, and actual gallium has a weight that is 70. Correct? Okay.
Yes, ma'am.
And for the Eka silicon, he predicted the weight 72, and the actual germanium has a weight 72.6, means near about same. Here, near about same. Now see, density he predicted 5.9, and actual density of a gallium is 5.94. Melting point he predicted for the gallium is low, and here they have given what? 302.93. Gallium, you might have cesium and gallium, you might be aware about, right? At room temperature, it like not room, slightly above the room temperature, it convert into liquid state. You might have learned into in grade 10 about the cesium and gallium.
Yeah,
Mercury
they
is the only,
melt above the room
you might have
temperature.
learned about mercury. Mercury is the only metal which exists into the liquid state, and cesium and the gallium, only these two metal, when temperature would be slightly above the room temperature, it convert into liquid state,
Yes, ma'am.
right? Yeah. So its melting point is less. Formula of oxide, he predicted formula would be E2O3, and actual formula of gallium would be Ga2O3, means exactly same what he predicted. And the
Yes.
chloride formula is ECl3, and gallium chloride is nothing but GaCl3. That is also same. Similarly, the density predicted for the Eka silicon is 5.5 by the Mendeleev, and actual density of germanium is 5.36, nearly same. Then he gave a melting point of the germanium is should be high, and that is 1231 degrees Celsius must be.
Kelvin, right?
Formula of oxide is EO2. It's been predicted by the Mendeleev, and actual formula is GeO2. Germanium oxide. Dioxide, you can say, because two oxygens are there. Now here,
Yes.
chloride is nothing but what? There would be whatever Eka silicons tetrachloride, ECl4. And here germanium tetrachloride, GCl4. Okay, so whatever predictions made by the Mendeleev is approximately same with a given and the actual values in a table. So you can
That
understand.
means he also predicted its valency and all that, right, ma'am?
Yes, he predicted its valency. He predicted the way how it will discover later. Means these elements were not discovered at his time, right?
Yeah,
Later
ma'am.
discovered. He gave the method by which method it can get discovered, right? Spectroscopy and all, everything was discovered. Few things are not mentioned in your book, but then actually he mentioned the way how it should discovered as well. So it was really very great help to the scientists. Those were discovering new elements. Understood?
Yes.
Fine. Okay, no issues. So this is a Mendeleev's periodic table. How many of you purchased the book for grade 11?
Not yet, ma'am. I am yet to receive it.
Just one, Dhananjay, Shreyasi. Show me thumb
No, ma'am.
at least
No, ma'am.
if you have. Do one thing, download the PDF with you at least for this
Yeah,
chapter.
that I have.
And yeah, please download this chapter's PDF. That would be with you. Okay. And go through the Mendeleev's periodic table, because in the next period we are going to see Moseley's modern periodic table. What is the difference in between Mendeleev's periodic table and the modern periodic table, that we have to discuss thoroughly. So if you have a textbook with you, or else at least PDF, or else one of the print of Mendeleev's periodic table and the modern periodic table, it will be a great help to understand thoroughly all the things. Clear?
Yes, ma'am.
Fine. So I hope whatever I taught, I have explained, you might have understand clearly. Because Dhananjay and about Jaswant I know very well, because they are my regular student. Today you have joined Shreyasi. Do you find any difficulty to understand anything?
No, ma'am. No difficulties.
Everything is okay?
Yeah,
Actually,
ma'am.
the previous chapter was quite tough, and that time you were not there. So go through the video. If you find any difficulty, please let me know.
Ma'am,
Okay?
you said this was the first chapter?
This is the second chapter. First
Okay.
chapter was some basic concepts of chemistry. In that we have
Oh,
learned,
okay. The one which includes the
yeah, we
atoms
have
and
learned about the mole concept. We have learned about the
okay.
stoichiometry in that.
Oh, yeah.
Okay,
Got it, ma'am.
fine. If you face any difficulty, feel free to connect with me and get your doubt clear. Fine.
So, ma'am, right now we have only you have only done these two chapters.
I gave you syllabus, I guess, early. I think four to five chapters I supposed to cover within this 2 months, right?
Okay.
So this would be the second chapter. Just we have started, and earlier we have finished with one chapter, some basic concepts of chemistry.
Okay, ma'am.
Fine. Okay. So I
Yes.
think your next class should be started now, and I need to take your leave. Take care. We'll meet tomorrow again, same time. Okay.
Yes, ma'am.
Take care.
Thank you, ma'am. Bye, ma'am.